Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together.
This time, we will perform remote control operation of home appliances with a smartphone. This time, we will perform the operation check performed at the end first and check what kind of things can be done. This is the product that will be used for operation check. On the left is the ESP32 remote control that I made electronically. You can save the remote control signal and button name by setting the reception of the home appliance remote control. I put a home appliance light to operate in the middle. We have confirmed that home appliances can be operated with TVs and air conditioners, so we think that normal home appliance remote controls will be fine. There is a smartphone to operate on the right side. I have already accessed the ESP32 remote control with a web browser on my smartphone. The access destination will be the set IP address. Buttons that are not set as remote controls are grayed out in HTML, so it is difficult to see, but I created HTML with 10 buttons. The size and number of buttons can be easily changed with HTML. First, set up to receive the remote control signal. Switch the screen to the settings screen and enter the button name. Both Japanese and English can be set, but this time I simply turned it on. After entering, press the set button. At the bottom of the screen, the text receiving within 15 seconds is flashing in red, and the remote control signal will be sent to the receiving sensor within 15 seconds. If completed normally, it will be displayed as completed in red like this. If it fails, it will show as failed. When the remote control signal reception setting was set, the light in the middle also reacted and turned on, so I turned it off immediately. When the receiving sensor senses the remote control signal, the signal and button name are saved. Even if the power of ESP32 is turned off, it is memorized, so once you set it, you don't have to do it again and again. Now that the save is complete, send it. You can operate home appliances by pressing this button. This time, the lighting and turning off of the light are the same remote control signal, so it can be operated like this. When the transmission is completed successfully, it is displayed as sent completed in the message column. If this also fails, it will be displayed as failed. This completion does not mean that it has reached the home appliance, but that the ESP32 has successfully completed the transmission process. Failure is displayed if it cannot be completed normally, such as when ESP32 access fails. If you save it as a bookmark in your smartphone's web browser, you can easily access the remote control you made and control home appliances like this. I have confirmed that the home appliance remote control that I will make this time can do. Although the order is back and forth, we will understand the program to be realized. As I told you, I will make a home appliance remote control with a smartphone. You will understand the implementation of EEPROM and ESP32 and the operation of home appliances by saving and reading remote control signals. Let's start with the table of contents. Here is the table of contents. First, from the overview, we will understand the implementation and programming of EEPROM. Programming uses not only Arduino but also HTML and especially JavaScript, so it may be a little complicated, but I would like to understand the overall operation. How it works is important. Move on. This electronic work will eventually become a series of making a smart remote control, and will be distributed in a total of 7 videos. When completed, it can be operated from a smartphone, and we will realize home appliance operation from the outside and AI speaker cooperation. This is the 6th time, and it is a home appliance remote control with a smartphone. Next time, at the end of part 7, we will implement the part related to the cloud, so this time we will complete the remote control function. For indoor use, all functions will be implemented. Since the hardware has been completed in the 4th infrared transmission LED, in this 6th installment, we will use that hardware to program the software. If you want to understand the items used, circuits, wiring methods, etc., there are links in the summary column, so please check videos 1 to 4. As for the software, in the previous videos, we have understood individual functions such as sending and receiving remote control signals, Wi-Fi and web servers. This time, I understand the contents, so I'm going to proceed without explaining it. It is difficult to give a concise explanation, and if it becomes too long, it will be difficult to understand, so please refer to the link in the overview column for the video you want to check for individual functions. In addition, since the source of the program is open to the public this time, I think that it may be understood one by one. Let's move on. As for the development environment, we will use Arduino. It is widely used for learning all over the world, and there are many functions such as libraries provided, and there are many learning materials on the internet. It is easy to understand and easy to use, so I will continue to use it this time. Move on. EEPROM is a type of non-volatile memory, that is, memory that can retain memory even when the power is turned off, and ESP32 can use part of flash memory as a pseudo EEPROM. SPIFS treats it as a file, so I think it is suitable for slightly large data. For storing small data, EEPROM can be used by specifying the data type and memory location, so I think it is easier to handle. This time, SPIFS saves remote control signals and EEPROM saves button names. A program that uses EEPROM first loads the library and specifies the size to be used with begin. This time, it is 650 bytes for 10 buttons. 65 bytes per button. Write with put and read with get. In the case of writing, it must be executed with a commit at the end. Move on. This is the file structure of the program used this time. The Arduino program consists of 4 files. Next, in the data folder used by SPIFS, there are 2 HTML files and 1 JavaScript file. The favicon file at the bottom is not necessary, but I prepared it. This is the image file of the icon and is only displayed in the browser. If you look at the console such as Chrome, you will get an error, so I prepared it. This data folder will be uploaded to ESP32 and used as a file. These files and folders should be available in this configuration. Move on. The 4 Arduino files are displayed separated by tabs like this. Although the files are separated, there is no problem to program in one file. It means that tabs are not separated either. It is divided into functions for easy understanding. There is no difference in operation between 4 files and 1 file. Move on. As for the Arduino program, we have understood remote control transmission/reception, web server functions, etc. by the 5th part, so let's understand the newly added contents this time. The added part this time is that the remote control signal is saved in a file, and the button name is saved in read. I would like to understand the contents. This is a program that saves remote control signals in a SPIFS file, but since we have obtained the time intervals between the presence and absence of signals from the 3rd remote control reception sensor, we will temporarily save the obtained contents in an array. It means that the obtained array is written to the file. To write to a file, the file name is determined on line 104, and the file is opened in write mode on line 107. On line 109, first write the number of times with and without a signal. After that, the for statement from line 111 writes all the times for the time interval of the signal. Finally, on line 115, the file is closed and the program ends. Writing to the file is now complete. Move on. We will understand the program that saves the button name in EEPROM. First, define the structure to be handled by EEPROM. This time, we will save the button name, so define a 65-byte char type. Since it is 65 byte, it can handle 60 characters in English and 30 characters in Japanese. Variables for storing the button number and button name are defined on lines 76 and 77. Next, on lines 80 and 86, we get the data sent by the HTML request from the smartphone. On the 91st line, the string type is changed to a numerical value, and on the 99th line, it is used to calculate the memory location. Line 93 prefixes the button name with an O:. This is included to clarify that the data exists. This is to make a clear distinction between garbage data and data that exists. The button name to be saved is saved in the structure on line 97. Writing is done on the 100th and 101st lines. You have now written to the EEPROM. Move on. Now read out. The button name will be displayed when the screen is displayed on a smartphone, so we will implement it for that purpose. In other words, we will create the data that responds to the button information. Add response data to the variables declared on line 66. In the for statement from the 70th line to the 88th line, the data of the EEPROM memory for 10 buttons is read, and if it exists, it is added to the response data. Whether it exists or not is determined on line 78 whether there is an O:, added at the time of writing. Finally, on line 90, we add data to close the parenthesis. The data to be sent is in JSON format and will be sent in the data format shown here. Move on. From now on, it will be the HTML and JavaScript of the web. Web technology has technical elements and design elements, and I think it is a broad and deep technology. It's difficult to cover everything, so how it works is important, so I'd like to focus on that point. Of course, the source file here is also open to the public, so please refer to it. First, the ESP32 microcomputer treats HTML and JavaScript as file data without understanding the contents of the HTML and JavaScript as data returned by the web server. The web browser in the smartphone understands and operates these programs. As for the HTML content, the style sheet and JavaScript are defined in the header tag. JavaScript has a lot of content, so I didn't describe the programming here and put it in a separate file. There is no problem in writing it here, but it is written in a separate file so that it can be easily understood as a program. The style sheet sets the design preferences. Screen and button size, background design, etc. are defined here. JavaScript communicates with ESP32, rewrites HTML, and realizes many functions. This time, we also display the button name and status, and also control the transmission and reception of the remote control. Go back to HTML. I am trying to display 10 buttons in the body tag. Since the table tag is used to display the buttons neatly side by side, the lines are not displayed as a table. A status display is provided at the bottom to indicate completion and failure. Move on. When operating from a smartphone, important functions such as communicating with ESP32 are programmed with JavaScript. Again, the Arduino program runs on ESP32, but this JavaScript is a program that runs on your smartphone's web browser. First, about this top left part, this onload is executed when the JavaScript is loaded. Here I am running a function that updates the button name. A function that the program on the right updates the button name. Make a request in HTML, get the button data from ESP32, and display the button name on the smartphone screen. Move on. This function does the transmission processing of the remote control. First, it determines whether it is being processed, and if it is not being processed, a transmission request is sent from the smartphone to the ESP32 in HTML. The result is displayed in the status column according to the response from ESP32. Move on. This is the remote control reception setting processing. Similarly, it determines whether processing is in progress, and if it is not processing, it requests ESP32 to receive processing in HTML. The result of reception setting is displayed in the status column by response. Move on. This is a function that blinks in red during reception and a function that displays failure processing. Flashing every second is achieved by setting a timer every second and calling the same function again. The final failure display function is a function that simply displays failure in red in the status column when called. As mentioned above, although it is simple, we have also confirmed JavaScript. Now let's understand how the whole thing works. Since there are many related files, let's check the overall behavior when displaying the top page. First, access the IP address with a web browser on your smartphone. In that case, send the HTML file using the ESP32 web server function. On the smartphone, the HTML file is read and the JavaScript file is specified, so a request is made to acquire that file. In response to that request, ESP32 will send a JavaScript file. Next, the smartphone reads the JavaScript file and executes onload, so it requests button information. ESP32 reads data from EEPROM, creates button name data, and sends it. The above is the operation when the top page is displayed. Up to this point, we have confirmed the program and its operation. All source files, including HTML and JavaScript, are available on the Hobby IT site, so please refer to them if necessary. If you write this program to ESP32 and run it, you will be able to operate home appliances with your smartphone, as you can see at the beginning of the video. Regarding the writing method, Sketch is understood in the second LED edition. Also, please refer to the 5th article about uploading the data folder handled by spiffs, if necessary. This time, all the functions as a remote control have been completed. Next time, we will check the cloud-related programs and settings for operating from the outdoors and for linking with AI speakers.
We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.